the steering linkages in brief. We know that steering system is an assembly of linkages which provides the directional control to the vehicle. Other than this, a steering system is also responsible for providing perfect steering condition and also minimizing the tire wear. Now let us understand this assembly of linkages which connects the front wheels to the steering wheel. On the basis of the suspension system adopted, steering linkages are of two types: steering linkage for vehicle with rigid axle front suspension and steering linkage for vehicle with independent front suspension. Let us discuss each one by one. Steering linkage for vehicle with rigid axle front suspension. A typical steering linkage layout can be shown as: it consists of a steering column attached to the steering wheel, which is further connected to a steering gearbox. The cross shaft of the steering gear is connected to a drop arm, also known as pitman arm. The lower end of the pitman arm is connected to the link rod through a ball joint. The other end of the link rod is connected to a link rod arm through another ball joint. The other end of the link rod arm is rigidly attached to one of the stub axle carrying the wheel. Now both stub axles have a forged track rod arm, which is rigidly bolted to the wheel axis. The other ends of these track rod arms are connected to a track rod with the help of ball joints. These ball joints are designed in such a way that it has an expanding spring which compensates for wear and misadjustments. Also, an adjuster is provided on the track rod, which provides room for track rod to change its length for adjusting wheel alignment. Now, when the steering wheel is rotated, say towards right, the steering gearbox swings the drop arm forwards, thus imparting a near linear movement to the link rod. This movement is transmitted through the link rod arm to the stub axle. The stub axle turns about its pivot, that is, its kingpin, and thus provides the steering. This pivoting of the stub axle also moves the track rod accordingly, which as a result causes the other wheel to steer. Thus we can say that only one wheel is positively steered. The use of steering gear provides mechanical advantage, as only small amount of effort is required at the steering wheel to apply much larger force to the steering linkage. Also, it provides desired velocity ratio, so that much smaller movement of stub axle is obtained with large angular movement of the steering wheel. Steering linkage for vehicle with independent front suspension. Before we study the steering linkage for independent front suspension, let's first understand why we require a different steering linkage for independent suspension vehicles. In the case of rigid axle suspension, the solid axle beam ensures the movement of stub axle in horizontal direction only. Therefore, there is no vertical deflection of the suspension, and hence there is no change in track rod length. But in the case of independent suspension, there is no solid axle, and both stub axle can move up or down independently, due to which the distance between ball joints ends of two track rod arm is continuously varying. That's why a different steering linkage is required for independent suspension. Now, a typical steering linkage layout for vehicle with independent suspension can be shown as: here the track rod is divided into three pieces. The centerpiece, also known as the relay rod, is connected at one end to an idler arm, which is supported on the body structure. On the other end, this relay rod is connected to the drop arm through ball joints. Both left and right side track rods are connected to the relay rod at one end. Their other ends are connected to a track rod arm, which is further connected to the wheel axis. Here, the relay rod is restricted to move in horizontal plane only, and the movement in vertical plane is provided by the tie rods about the end ball joints. Now let's summarize the steering linkages as: